Hi, Professor Chen. This is my first video for your third assignment, and this video is about the question one. And as before, let me introduce this question first. There's only one condition this question offered, which is let the probability x equal to k equal to b multiplied k minus 1 power of p, and k equal to 1, 2, 3 to the infinity, and the p located in the range between 0 to 1. And the first question is find b so that the probability x equal to k represents a probability mass function. We've already learned the probability density function, and the probability which is for a continuous random variable, and the probability mass function is just like a discrete version of a probability density function, which is when we add the probability of all different possible circumstances together, we can get 1, just like we integral the probability density function from the negative infinity to the positive infinity equal to 1. So let's work on this question first. And as I said before, the sum of the probability of different possible circumstances is equal to 1, which we can get this equation. And apparently this is a geometric sequence here, and it's a little bit hard to solve this geometric sequence. So we can just multiply both sides by 2, so we can get this equation here, and then we use the first equation to minus the second equation, just like this, so we can get this one. And this one is really easy to solve. So the left side of the equation is equal to b multiply 1 divided by 1 minus p, and the right part is 1 minus p, so we can easily get the answer b equal to the square of 1 minus p. And the second question is find the ex, which is the expected value of x. And we can just simply apply the definition of the expected value, or the mean of a discrete random variable is this. And the definition is this: the ex equal to the sum of xi multiplied pi, where pi is the probability when x equal to xi. And we can just simply apply this definition, so we first can get this equation. We just need to use k to multiply the corresponding its corresponding probability, so we can get this. And as the first question, this is a little bit hard to solve, and we can not directly find the answer of this. But we can use some information offered by the previous question and the condition and this question. We already know that when b equal to the square of 1 minus p, the p x equal to k represent the probability mass function. So we can get this. So we can get this one, and we can just use this one to solve the value of this. The first we need to move the b to the other side, then we differentiate the both sides, so we can get this one. We can realize that this part looks really similar to this equation, the right part of this equation, and so we can just use this to form this one, and then we can get the answer. So we need to move the second part to the right side, and then multiply both sides by bp, so we can get the left side exactly the value of expected value. And so we can get the answer. The answer is ex equal to 1 plus p divided by 1 minus p. And the third question is find the expected value of x, square of x, and it's just like the second question. We can just simply apply the definition of expected value, which is like this, to find the answer, but it's a little bit hard. It's still a little bit hard to directly find the value of this. So we can just use the same method like the second question here to find the answer. The answer is this. And the third question is really simple. We can just use the result of the third question to minus the result of the second question, so we can get the answer like this. And the fourth question is, let the p equal to 1/3. Find the conditional probability mass function this p x equal to k when x between 2 to 5. When p equal to 1/3, we can just easily to calculate the value of the p k equal to 2, p k equal to 3, p k equal to 4, and p k equal to 5. Like this, we can calculate this, and we can divide it into several circumstances here, and we can know when k less than 2, the probability x equal to k on the condition k between 2 to 5 is 0, because the union k x equal to k and the x between 2 to 5 is 0. And the other part, when k greater than 5, the union is still 0, so the probability is 0. Exactly when k between the 2 to 5, and we can get the specific answer of this question. And we can know that the probability x equal to k on the condition x between 2 to 5, we can just use the probability x equal to k, because the union of x equal to k and the x between 2 to 5 is just x equal to k, because the k between 2 to 5. So we can just use the probability of x equal to k to divided by the sum of these four probability together, so we can get the answer. So we can get this conditional probability mass function like this. So the answer is this. That's all. Thank you.